our next speaker actually told me that a lot of current speakers at Craft pretty much shaped his career. So why don't we welcome and give a round of applause to Dennis Doomen.
Wow. This is pretty awesome, man. This room is like unique as a speaker. Okay, awesome. And she even pronounced my last name correctly, which is awesome. I'm Dutch, I'm from the Netherlands. And I'm going to be sharing my 25-ish, actually it started at 19, I think it's actually 28 or something, I lost track. My laws, and what you really should be hearing is my guidelines, my heuristics, that should make you productive, reach the plateau of productivity if you practice unit testing and test-driven development. Okay, that's nice. This thing doesn't work anymore. Good start. It worked a second ago. Now it's working. About me, as I said, I'm from the Netherlands. I'm doing this for almost, a little bit more than 26 years. I'm turning 50 this year. And I'm in the .NET space. So any .NET people, C# developers here? Oh, that's sad. I'm the only one here. Okay, oh, sorry. Okay, 2 or 3. Okay, these are my fans now. I have a blog where I talk about the things that I care about, which is not just .NET, it's everything around being a professional, about architecture, about process, about tools, about teams, about people working together, the most important, most difficult part of our job. I have a couple of open source projects which you don't care about. If you're in the .NET space, you might actually know this one, which is my little open source project. But enough about me. So, why the plateau of productivity? The thing is, if you're adopting some kind of new technology or new practice, usually you start at the technology trigger, like the lower left corner. I can use this thing here. This is where you start. And then you go up and you become enthusiastic about it. You start to convince your clients, your colleagues that you should practice test-driven development. You start maybe even do an internal talk. You go to conferences and stuff like that. You create a pluralsight training, how awesome test-driven development is. And then at the top, you somehow realize that you may actually have unrealistic expectations. That's what the peak of inflated expectations is about. This is the Gartner hype cycle, by the way. And then, of course, you become a little bit negative. You start to tell people, TDD, you shouldn't be doing, it will lead you to the dark side. You'll create YouTube videos and pluralsight trainings, like you are going to Craft and tell everybody how crap TDD is. But then, at some point, you realize that there's this slope of alignment. You realize that every tool, whether it's solid, dry, and if you went to Daniel North's session, you should have heard about that. TDD, unit testing, event sourcing, microservices, they have pros and cons. They are applicable in a particular context. So what I'm going to share you is some of the guidelines or heuristics I use myself to be successful with test-driven development and unit testing. So let's start a little bit with the testability, to design for that. The first thing is, nobody in their clear mind is going to write a unit test without having any code. Even though the books will tell you, it doesn't work like that. The thing you do, you start creating some kind of structure. You're going to create a mental model of the classes and the types. You're going to try to maybe draw that out on a piece of paper. Maybe you even code it out. You sketch out the code, think about the API, then you start going through the whole cycle and use that to drive the test. This is kind of the cycle that I always show you. You don't have to be able to read it right now, but it's good for reference later on. Then you use those tests to further drive the design of your system. You start to think about the APIs. This, for example, is a bit of commented out code that is part of a pull request for my library that I've been working on for over a year. And because I have so many other interests, I sometimes forget about it. These are little, let's say, breadcrumbs that I left in my code base. So the next time that I look at this, I remember the particular scenarios that I was going to be coding out. So I haven't implemented them. I thought about them while designing my API and kept them here for reference because, I usually forget what happens before the weekend or after a speaker's dinner with too much rum and cola. Next thing is, and that's really important, you need to organize your code by functionalities or capabilities, something functional. Don't create a folder with repositories or services or helper methods or something like that. Try to organize your code base in a more functional way. I like to use functional slices, as you can see in my slide deck, which really helps structure and organize my code in a more logical way. Ideally, this is aligned with fancy terms like bounded context from domain-driven design. But this really changes the way I look at the code. It automatically creates some kind of internal boundaries in your code base. Another thing you can do is use the dependency inversion principle, which is, I think, maybe the only thing in Solid that still has value for me and can be explained. For example, look at this picture. You have an order processing module, like a domain module, and it depends on an interface, in this case an iStore order, some kind of generic thing, which is very, very common in C# and Java, and a generic repository. The problem with this is the code in this repository thing is probably very generic, and generic code is very difficult to optimize. So one way to change that is to invert the dependency and actually say we have the same module. The difference now is the module itself defines a contract that it wants to be implemented. So the difference is the contract is owned by the business layer or the business logic, or if you use an onion architecture, the inside, the core of the architecture, and then you have the same technical implementation implementing it. It looks like, oh, what's the big difference here? I mean, who cares? The big difference is that ownership is up there. So if multiple modules need some kind of similar interface or similar contract, they will all implement that. And that is really valuable because it reverses dependencies and also makes it much easier on the bottom side to optimize. Because yeah, you have actually very specific methods like get incomplete orders. You can optimize that. You can build a specific view or add a clustered index to a SQL Server database or something, or a specific index if you use a NoSQL solution. The dry, don't repeat yourself, is something you learn when you start as a junior developer. You know, you start to hack around, you make it work, and then your senior developer will tell you, yeah, but we don't want duplication because we have to fix the same bug twice. My point is actually that you should be careful with dry. Dry, don't repeat yourself, is a good thing. It's a good thing, but you need to do it within the boundaries. And again, you see the same functional slices. So you see basically a duplicate surface here, and there's a duplicate surface here, even though it's doing the same thing. And there's lots of different stuff that is called duplicate. That's fine, because dry can also lead to coupling, and coupling generally is a bad thing. So be aware of that. Apply dry within the boundaries. Then about the scope, because yeah, we all know the term unit testing, but if you ask somebody like, what's a unit? Yeah, you can be ending up in a very religious debate. So I have a slightly different approach. For me, I try to align the test scopes, the unit between quotes, with my internal boundaries. So if I have a functional slice like this, probably the scope of my test is the entire slice. Like, really? Yes? Yeah, I do that. However, and I do it with the other slice as well, I may actually have an individual surface that is very generic within that boundary, and then I decide to test that separately. That's totally fine. The default that a lot of people tell you is that you should test every class independently or every functional component if you're in the JavaScript, TypeScript world. Doesn't make sense to me. It really doesn't make sense. Align it with your functional boundary. And again, you don't have to agree immediately. I just want you to think about it. When you go back after the weekend, you start to rethink, like, hey, what does this guy from the Netherlands actually tell me? Of course, there's always some specific functionality that's very tricky that you do not want to duplicate, and you can see that on the bottom of the slide in what we call the shared service section. And that's maybe the thing that you should take away from this meeting. There's not a single way of doing things. There's not a single rule that always applies. It really depends on the situation. It's a scale that you have to go through. What else? Yeah, sometimes you do have to test smaller. Maybe within that, this blue box, and this is an enlarged version of that, there is a piece of component that's so critical that you really want to create some really fine-grained tests that may use mocking or something to verify that it's not accessing the database unnecessarily, something you cannot easily test except we're using performance tests. That's also totally fine. So generally align with the internal boundaries, and if you want to, Test a little bit smaller. Totally okay. As you can see in this picture. Things that are designed to be reused should be tested separately. That is something else than saying something is reusable. Because all our code, well, I mean, most of our code is potentially reusable. We all write awesome code, right? But that's a difference. If it was designed to be reusable, then you should test it separately. If it wasn't, if it's just a part of a bigger whole, then test it as part of that bigger scope. That is a heuristic that works for me really well. Well, actually, I just said it. Treat that, if it's not reusable, treat it as an implementation detail. I sometimes even treat the database or a particular table as an implementation detail. And if you have doubts about it, I'll be around for the next 2 days, so you can say hi and we can talk about that, and I can give you some examples. That also means if you look at a folder structure in your IDE, that things that are in adjacent folders next to each other typically should be also treated as separate boundaries that you should test separately. Kind of obvious then. And the other ones, test the real service area. What does that mean? So if you in the .NET space and you want to build HTTP APIs, REST APIs, if you want to call it like that, usually there's a class behind that, and they call them controllers. I don't know why. I've actually seen people create an instance of that controller class, and then in the test actually call a method directly. My point is, wait a second, that's an implementation detail. The fact that you're using, I don't know, .NET, ASP.NET Core, whatever, which is common in that space, is an implementation detail. What you really were doing is building an HTTP API. If you build an HTTP API, then what's the service area that you should be testing? Your HTTP API. You should be sending an HTTP request with certain headers, and you should be observing response. Everything else is an implementation detail. If you create an abstraction on top of a database, and that abstraction has methods to operate or interact with that database, I would call that method, but I would also call another method to observe and verify whether I've actually, if that thing did what it does. You shouldn't actually go into the database from your test with some SQL statement. Then, and again, there's exceptions, there's always exceptions, but the principles don't do that. I think you actually have an example here. Here you see on the top that I'm creating this specific controller, which is a .NET type, and then at the end I'm doing some kind of assertion on that method, whereas at the bottom I'm actually calling an HTTP API. You even see the route, because the route for me is part of the contract of an HTTP API. It is, because that's how you select which point you want to enter. And then I verify that the response complies to a certain structure. I'm not actually using the JSON here. I could do that, but there's reasons for that, which we'll come to in a later point. And that, you know, you probably overheard that I mentioned the database. I think personally, it's totally fine to include the database in tests, even if you call them unit tests. If the sole purpose of a particular class or type is to interact with the database, I would like to include the database. And that's quite okay. These days you can use SQL LocalDB, or if you use a NoSQL database, they often have an in-memory representation that's completely compatible with the file one. If you need to work with SQL Server, for example, then you can run it in a Linux container. That works. It's blazingly fast. There's tools for that, that you can do that. Works with Postgres, works with SQL. Oracle is a bit harder. I'm sorry if you have to work with Oracle. Nothing against it, by the way. A little bit. So that's totally fine. You can see an example. This is again from the .NET space, how that works. The first one is actually using a test data builder pattern to build a container running Linux. You can even see it with SQL Server in it, with a very secret password. And it works. It's beautiful. And then I can use it in my test. As if so if that code is actually interacting with SQL Server, I can actually see that it works, which is what we want. We used to be told that we should create some kind of abstraction to hide away the database. But yeah, if that code is supposed to interact with the database, why would you hide that fact? Then what are you still testing? Becomes a bit of a weird thing then. Same as that you can also use different styles. I don't know, people using range act assert syntax? No, nobody's doing, is anybody using unit testing at all here? Okay, a couple of people. The rest is managers or something, I don't know. Yeah, no. Product owners, yeah. consultants. They don't write code. But the range act assert is basically just a grouping within your tests to say that, yeah, as it says, this is the range part, this is what the act is, this is where I interact with the subject under test, and this is the assertion. The thing is, sometimes you have code that is more orchestrational. You call a method, it will interact with other parts of the system, across functional slices, and then using a more like a behavior-driven development process is better. It's not really BDD. There's no business people involved. They shouldn't at this level. I never saw that working, by the way. But it gives you the same style. You get like the given, when, then constructs. This is something that how you can do this in .NET using one of the libraries called Chill. You see the given, when, then here. You see a little bit of a given here. You see the when. And then there's actually two thens here. There's actually two things that will happen as a result of that action. And with normal tests, you cannot do that. With this behavior-driven thing, it's fine. And you can mix and match. Some types or some classes, some functional components are more suited for this AAA syntax. Other ones are more suited for this BDD kind of thing. And you can combine that. Again, there's not a single tool that will solve all your problems. Well, this is, I think, one that causes a lot of discussions. Not today, because you probably all believe me. Because the term unit is so convoluted, I kind of stopped using it. The thing is, it doesn't really make sense anymore. If your unit becomes bigger, you'll probably end up with people trying to debate whether, oh, but that's an integration test. I don't care. I don't care. I only care that you chose the right scope that makes sense for your architecture. Whether you call that a unit test or an integration test, I don't care. Stop talking about it. Don't even try to define what an integration test is. It doesn't really help, because it's only about being dogmatic about things. Sometimes you need a bigger scope, sometimes a smaller scope, or whether you call it a unit, I don't care. Again, bigger scopes, really bigger API level testing, UI testing, yeah, they're very clear, of course. I'm not talking about those. Some guidelines, maybe a bit stupid. Write your code like you write your production code, right? Assuming that you actually write well-maintained, readable, discoverable production code, because if you don't listen to my advice. Make your test code even better than your production code. But in general, everything that you should apply to your production code, I don't know, clean code principles, some element of solid, dry, inline comment, yes, I like inline comments, also should apply to tests. Except with the dry part, you have to be careful. People say, but that's completely obvious, isn't it? Well, I've seen test code that really hurts my eyes. And this is kind of the ultimate promise of test-driven development. If you write your tests in such a way that they're easy to read, the cause and effect are obvious, the name of the test is very functional, you could use them as documentation. They will give you an indication how something is used. If I look at my own open source, I see people shaking like, no, not our code. No, not our code. No, just kidding. If I look at my own open source project, Fluent Assertions, which has like 250 million downloads these days, I really use the test as documentation. I want people to be able to go to the tests and get an understanding how to use my API. Also, what kind of behavior to expect. The test should be self-described. I really care about that. And I've seen it work really successfully in projects. Also, a common practice I see a lot of people when they do dependency injection is they have a class, and what do? They extract an interface with the same name and use that for dependency injection. That is wrong. That is strong. That's almost like dogmatic behavior. We shouldn't be doing that. It's completely okay to inject a concrete class, but within the boundary. Remember the slices that I showed you earlier? Between slices, you probably want to have abstractions to define what the contract between those boundaries are. But inside, you don't need all these interfaces. If you're in the .NET space, you probably know that they always take the class name, slap an I in front of it, of interface, and that becomes the contract. That doesn't work like that. That would be a violation of the interface segregation principle, which Dan tried to debunk. I still see value in it. So that's totally okay. Between boundaries, you typically want to use mocking there. And then having those contracts actually helps you. Inside, No. So here you can use mocking, and there you can use mocking, and here you can use mocking, but there I wouldn't use mocking. I don't know if you know, but there's actually groups of people that either say you should always use mocking, or mocking is always bad. I think that's a signal, like a symptom of this, thrall of disillusionment and inflated expectations. People haven't realized that they actually, a mocking has value as well, like any tool. Sometimes you need it, sometimes you don't. However, if you start to return mocks, that return mocks, that return mocks, then I would wonder, like, are you actually testing at the wrong scope? I don't know if you can read this C# code, but this guy created a class called the database manager. What's the role of the database manager? Manage the database, I guess, right? So yeah, it's a good name. One of the few cases where using manager is actually a good thing. I'm not referring to the managers in the group. But to be able to test that, this person said, yeah, but I want to hide the ugliness, and the ugliness is the database. So I'm going to create an abstraction, an database adapter, with one implementation, by the way. Yeah, but so how does the manager actually get the adapter? Yeah, you need a factory, because I read the blue book, design patterns. I thought somebody told me, like, I need to use all these patterns, I need to be able to check them off. So now I'm returning mocks of mocks. This was created, this is an example from real production code, a .NET developer that has 20 years of experience. That doesn't say anything about .NET or C#, don't get me wrong, more about the person, that he was overly applying the principles, the design patterns, which is never a goal, just a communication mechanism. That's what it is between us developers. Well, here you can see the range acted and asserted as I mentioned before. Should probably reorder the slides. Basically a comment, and you would say, this test is so small, do you really need it? Probably not. Usually the tests are a little bit bigger than this contrived examples, but I actually still do it. Very dogmatically applying these comments. It helps people sometimes. They can easily see what the subject on the test is. And if you're not a C# developer, I'm sure you can read this. So make it clear. One of the most important rules that I use to help people understand how to rewrite and how to clarify the purpose of a test is to make sure that you hide the things which are not important for that particular test case. At the same time, the reverse is also true. Things which are important to understand that test, like the route I saw you in this HTTP request before, are very important to show. So hide what's not important, show what's important. Very simple rule. I hope you will apply this next Monday. Yeah. Here you can see how I usually do that. Test data builder, it's a nice pattern. It's actually from the Java world. And object models are also patterns that I use a lot. They can help you extract, let's say, ceremony from your test cases. But again, you have to be careful. If you can hide it from one test, it doesn't mean you can hide it from all tests. Maybe there's a particular test case where you do want to show that. That's something you have to be careful. And that's why dry, don't repeat yourself, is very dangerous when you write test code. Quite often you just want to repeat things to make it more clear. And this is how I use this. New test host builder, using some using methods. The cool thing about a test data builder is that if I call an instance of that test data builder, call build on top of it, I still get an object which is functionally correct. And that's very useful for tests, especially if you need to build all kinds of complicated domain objects. I'll probably, at the end when I share the slides, I'll also share some links to the relevant articles. Well, maybe this is a bit of a stupid one. But who has actually wrote a test and it was green and it never fixed it? Like, you had a bug report, and the first thing you did as a good TDD practitioner, you tried to create a test case that should fail. Who actually did that and actually had it fail, had it succeed unexpectedly? Yeah, see? I had that, yeah, see? That's very annoying. So it's very important to make sure that test fails first before you fix it. And then, of course, you fix the implementation and make sure the test succeeds. Sounds a bit like an open door, I know that. But I've seen many cases, including myself, where I created a test case, it was green, like, huh? That was not supposed to happen. And it turned out there was some internal design issue. Or I was testing at the wrong scope, or something wasn't really properly designed for testing. By the way, for me, A bug report actually means I missed a specification. I treat my test like that. Inline literals, that's also interesting. So instead of doing this at the top of my test case, having all these constants defined, I personally experience that using them in line like this is quite often much more readable. I also do use things like the client as a string, or a client, or a customer, to emphasize that this is just information that's not that important for the test. Sometimes I still have to show it. It's not a conflict with my earlier rule, but using all these definitions at top doesn't really help, except with GUIDs. I mean, I don't know about you, but I really suck at remembering GUIDs by heart. So then having some variable makes sense here. Another thing is that you should not use the code that's being used in your production code also in your tests. So imagine that you have this HTTP API. There's some code behind that will return some data. Usually it's a class or something like that that represents the data, a DTO, data transfer object. Don't use that same DTO in your test code to assert it. Why not? Because it's nice, right? I can change the structure of my DTO because, requirements change, and then my test doesn't fail. That's nice. No, that's wrong. The point of that test is that you're verifying that your HTTP API is complying to a contract. So changing the internal structure should never break the contract. It should actually fail your tests. And that's why in the .NET space, I use something like should be equivalent to, and in this case, this is wrong. This is the correct way. You compare it to an anonymous type, which is something that is pretty common in .NET, where I'm saying that I only care about the state and account of that JSON object. Another thing which you will find is that even though that the HTTP response may be returning like an entire set of JSON properties, for that particular test case in this example, I only care about two things. That there's a property called state, which value is active, and there's a property called count, which value is 1. Everything else I don't care about. And that's actually why I created this library in the first place, to implement that. The other thing is, I think it's pretty obvious. You don't want to, well, I would rephrase it. If you're creating a test case and you need to attach a debugger to understand why the test fails, it's a symptom. It's not always avoidable, but in general, I try to make sure that the output of the test is so clear, I immediately know what's wrong with the test case. So sometimes, you would expect something like this. I'm comparing two object graphs, and I'm expecting this tool to give me information like, okay, which part of this object graph is wrong? That is important to do that. About naming an organization, a couple of rules. I use specs as a postfix. I never call them tests. As I said earlier, for me, the tests are specifications. They describe the expected behavior. They describe the way you can use the APIs, the parameters and everything like that. So it's a stupid little thing, but it really helps me emphasize that aspect of it. I do that a lot. Similarly, I group my tests in a way that, finding a short name is very difficult. I know that Roy Osheroff in the past used something like the class name, the method name, and then a very short expectation. I've also seen a lot of people using something like given something, it should do something, that kind of structure. The problem with that is as soon as you have a lot of these test cases, it becomes very hard to read this whole suite of tests, especially if they all deal with the same subject on a test. So I started to group my test cases using the capability of that something. Like here on the left, I don't know if you can see that, but you see like grouping like including, excluding, accessibility, member hiding, basic, downstairs browsability. These are all features of a library, and I have test cases that are associated with that feature, but I don't have to repeat the name of that feature in every test method, which allows me to keep the names smaller, shorter. In this case, it's just a nested class. I'm pretty sure you can do that in every language these days. Same about names. These days, I use names like this. They almost represent the fact. It's not like when this happens, then that should happen. That's too long. I've done that for a long time, by the way, but after reading some kind of article that showed me, that helped me understand that we should focus on the fact, I started to use very short names. Names that still convey the original purpose, but with the context, the class, the specs class on top of it, with the nested classes around it, it should be completely self-explanatory. If you don't buy it, you should probably look at the example code. But you can see things like, including all declared properties excludes all fields. Clear. Used to be like, when excluding all declared properties, it should exclude all fields. It's noise, doesn't really help. So using when and should, I kind of stopped using that. And that's total. If you don't like it, that's totally fine. I just try to focus on the fact and not on what is supposed to happen. So, 50 minutes left. I've done this talk in 1 hour. Apparently now I've done it in 30 minutes because you have so many questions.
Goodness, that's too fast.
It's way too fast.
Absolutely. All right. Can we have some questions, please, on Slido? If you did not ask your question, ask it now. And please also rate our speakers.
And I'll be around all day long as well as tomorrow. I know there's probably going to be questions because this stuff needs to sink in a little bit. I'm pretty sure it is. A lot of stuff is different than what other people say. I hope you think about it, start to sink in and start to question what you've been doing.
If you need some time to create a question, you can find Dennis around here. You will just find him, right? No more questions? Yes? If you are lazy to type, I will just come with you with a microphone. Yes? Wonderful.
Hey, thank you. So, given that we have AI tools that write unit that's blazing fast, what will happen to TDD?
So the question is, given that GitHub Copilot X can generate tests for you, and ChatGPT can do the same thing, that is great if you, for example, use code coverage. I didn't mention code coverage. If you practice TDD, then getting a 90% code coverage is perfectly fine. The problem with what I've seen, because I experimented myself, of course, is that AI tools can generate a working test, but they may not comply to the things I mentioned here. The point is, the test that it generates is nice to get the coverage, but over time, as I said, you will use the test to understand the behavior of the system. If the test is too small, then basically what will happen is you shoot yourself in the foot. A lot of people, when they start practicing test-driven development, they basically start creating very small tests. And then you have 20,000 different tests. The thing is, as soon as you need to refactor your code base, and you have to rewrite your test because of that, that's a signal that you chose the wrong scope, you have been using the wrong subject on the test. You still need to understand those tests. Also, if they fail. You know, if I look at test case, first thing is I look at the title of the test case. Do I understand what is it functionally trying to achieve? Then I look at the implementation. I guess there will be a time where an AI will be smart enough to really meet that standard, but I haven't seen that yet. But as I said, code coverage is, you can easily get 90% coverage when you use TDD. I use code coverage mostly as a means to get an understanding where we skipped something, where we missed something. And then being able to generate a test as a starting point is perfectly okay. Up to now, I've played a lot with Copilot. I see that as a tool that provides me with an initial implementation that gets me started, but I never treat it as the final outcome. And that applies here as well. I hope that answers your question. That's a pretty good question, by the way. Very accurate.
Wonderful. So people feel psychological safety well enough to ask more questions. How would you introduce TDD to a legacy code base?
Yes, so there's a speaker. I'm not sure if he's here physically, Michael Feathers, or if he's joining virtually. Who? I saw that. Michael Feathers is one of the persons that really, as you said at the beginning, defined my career. And he wrote a great book called Working Effectively with Legacy Code. And it talks actually about taking an existing code base and creating a suite of tests, which he calls characterization tests. They literally are ugly, they are unmaintainable, but their sole purpose is to create a temporary safety net that literally execute and observe the behavior of the system as it is in the legacy state. And then you use that to gradually, identify seams and reintroduce individual tests for those seams. Because usually there's no internal boundary. It's just one blob of code. So use that safety net as a starting point so that at least you can change things and know that you didn't break anything. And then you start to incrementally, introduce seams in a code base, find things that are used together often, start to tree them, decouple them, and then create test cases for that. That's a very powerful technique. And the book is absolutely worthwhile. It's still C++. It's pretty old, but everything he wrote is still completely actual as of today. Hope that answers the question.
Thank you very much. Where to start with a team of developers who never wrote tests before and don't think about testability when designing code?
That's actually the biggest question if you start introducing TDD. Show them. Show them how it works. Do some coding katas, something like a coding dojos, to try that. See how it works. Or show them how other libraries are built. I mean, the good libraries that you use, whether it's .NET, Java, NPM, doesn't matter. Good libraries have test coverage. And you have, in fact, for me, it's almost like driving without seatbelt. I don't know if that's very common in Hungary, but not in the Netherlands, unless you love to pay a fine. But it's basically showing them. You will get a lot of, let's say, people saying, managers that will tell you, oh, it will only cost you twice the amount of time. This is true, by the way. It will cost you twice the amount of time to build the initial feature, but you will get it back many times. I know that. I have a project with 250 million downloads on NuGet. I would be too afraid to change anything if I didn't have tests. But you need to experience it. It's like moving from a traditional source control system to Git. Everybody's like, oh, it's really complicated, especially in the Microsoft space. Everybody's so used to have this WYSIWYG thing, and now you suddenly have to do Git commands. But as soon as you used it, like this is changing the way you work. It's the same thing. It's not a good advice because very hard. You can, of course, also, hire me as a consultant to help you with that. But yeah, show them and show other libraries. That's probably the best answer I can give.
Thank you very much.
This is not a question. It's
great talk.
Yes. Yeah.
Amazing. Maybe last question before we go on a break. How would you approach a Kubernetes microservice with TDD when all you do is integration tests?
That is an answer that we need to talk a little bit about it. It's a very good answer. I think somebody's actually soliciting for that free JetBrains license or something. That's very difficult to answer without understanding a little bit more about the context. So I'll be around. Ask that question.
AKA find Dennis, offer him a drink, and he will tell you.
What if you don't have requirements? Can you use TDD? Of course you have requirements. You just didn't write them down. Because code didn't actually appear out of thin air. You didn't create the behavior out of thin air. Same answer as I gave earlier, characteristics test. That's a good start. Just replicate the current behavior. Those are your requirements now. And then if you start to refactor, as soon as a test fails, you know you violated the requirements. Basically, you have implicit requirements. Hope that answers the question.
All right, maybe the very last question. What about test coverage % relevance?
I think I already answered that.
Then the very next one.
If you use SonarQube, anybody using SonarQube? No, you don't have to be afraid. You don't have to be embarrassed. It's a good tool, but disables, two things. Disable the duplication detection because it actually it creates a lot of friction. But I would say if you practice TDD, gaining or reaching 90% coverage is trivial. The library I'm maintaining has 97% coverage. It's not to boast about it, but it's so trivial because, you design your code from a testability perspective. Is 85% enough? Probably. Is 80%, 75%? I would still be impressed. Is it 35 or 27? Then I would be worried. Then something needs to happen. So you should see it more like a scale, And that's what it is, not more than that. It's a tool to give you a sense of maturity. That's about it. It's never a goal. Be careful. Because you can actually use an AI tool to reach that 100% or 97%, but you shouldn't because it's not going to help you. It should help you.
All right. I think for the rest of the questions, as Dennis kindly offered to talk to you outside of this stage, and we will let you go for the break. Let's say thank you for Dennis.